Alright, ladies and gentlemen, we have the log equation. Log of x plus the log of x minus 9 equals 1, and we're asked to solve it. Now, we've already learned from previous videos and class instruction that a log equation you have to check at the end to make sure that your answer doesn't cause either of these arguments to become 0 or negative, but we'll worry about that after we've solved it. The first step in solving a log equation is to convert it from log form into exponential form. The problem here, I can't convert from log form to exponential form when I see the log function used twice. So what I have to do is I have to do one additional thing in this problem that we did not have to do in our previous problems. I have to figure out a law of logs that I can use here to turn this expression into an equivalent one that's a single log. Well, hopefully you remember with the laws of logs, when you see a plus in the middle, that came from the product law. So what this is going to allow me to do by using the product law for logs is to turn this into the single log. That means I write the log function one time of the product. And x times x minus 9 is x squared minus 9x. So my first step here was to apply the product law of logs. Okay? My next step is going to be to now convert it into exponential form. Remember, when you see log, that's the common log, so that means the base is 10. Log base 10 of x squared minus 9x equals 1. Remember that the answer to a log function, the outcome, the output, whatever you want to call it, this number represents the exponent that this base is raised to give you this answer. So when I convert this, I start with the base, which is 10, I raise it to this power, which is 1, and that gives me the answer x squared minus 9x. So I have 10 equals x squared minus 9x. This is a quadratic equation, so I'm going to write it in standard form and hope that it factors. If it doesn't, I'll go to the quadratic formula, but I hope it doesn't get that ugly on us. So we have 0 equals x squared minus 9x minus 10. Okay? And this does factor. Quite easily, actually. This is not so bad. This is an x minus 10 and an x plus 1. And you can always remember to do the chin and the grin, the chin and the grin method to find out you get the right middle. Negative 10x is the chin, 1x is the grin, put them together you get negative 9x. So we have two potential answers here, namely a 10 or a negative 1. Okay? Now, before I write both of those answers, a 10 or a negative 1, before I accept them both, I come over here to the original problem. If I put in a 10 here, this remains positive, so the log of a positive number is good. 10 minus 9 is 1, that's still positive, so the log of a positive number is good. So we're fine with 10. That works. When I try negative 1, however, I'm in trouble immediately. When I put a negative 1 in here, I'm trying to take the log of a negative number. That's not going to work. Remember, the argument here has to turn out to be greater than 0. Whatever this becomes has to become a number greater than 0. Well, negative 1 is going to immediately kill it. So we ignore negative 1, we keep 10. So the solution set here would have the number 10 only in it. All right? So, we use laws of logs to start with. We converted from log form to exponential form, put our quadratic in standard form and factored it, got two answers. But when we checked the two answers, we found out one didn't work and one did work. So we only kept in the solution set the one that worked. And we're done.